All right. We'll say hello and welcome to everyone out there tuned in tonight on our YouTube channel, W5KUB YouTube channel, and also listening on International Shortwave, WBCQ on 7490. We're glad you're with us. Hey, and if you are out there listening on shortwave, you can always tune in on Tuesday night at 8 o'clock. Just go to W5KUB is the easy way to get there, W5KUB.com, and it'll take you to, there's little buttons there, it's video and chat, and it'll take you right to the video and chat room, and you can join us there. If you're out there, we'd love to hear from you tonight. Send us an email to tom@W5KUB.com, tom@W5KUB.com, and let us know where you're hearing the station, where you are and how you're hearing it and so forth. Also, if you will hit that subscribe button down there. It should be over there somewhere in the corner there. So hit that subscribe button. It helps us out a whole lot. Also, hit the like button, because that helps, the like button and the notify button, that helps YouTube to promote our channel to other people that are looking for similar type programming. We'd love for you to do that. Let's see, join our Facebook group. We've got a great Facebook group. It's for ham radio operators and shortwave listeners and electronic enthusiasts. Just go to Facebook and just search for W5KUB, and you will come up to our Facebook group of over 14,000 people, 14,000 members there. We'd love to have you join us there. Also, you can hear us on any audio podcast out there, from iTunes to iNet Radio to Google Play. Gee whiz, I've lost it. Here we go. iTunes, Google Play, iNet Radio, Spreaker, iTunes. So we're out there everywhere. You can tune in and listen anytime. You can download it. We've got a lot of podcasts out there that you can tune into. And again, we're on WBCQ up in Monticello, Maine on 7490. Relatively low power, probably about 50,000 watts. They've got a number of transmitters up there, but we're not high power. We're just 50,000 watts. So I hope you're hearing us well. Hey, so tonight we were talking about the All-American 5. I told you last week and showed you Glenn found us one. He found one at Hamvention. I'll tell you what, we've got a video of working on it. I'm going to show it to you. So we're going to talk about the All-American 5 tonight, and did we convert it to a transmitter? We'll find out a little later. Also, I want to talk about 6 meters. I'm getting really interested in 6 meters. Haven't been on 6 meters since about the 1960s when it was AM, but that is the magic band. And let me tell you, I'm fixing to put up a 6 meter simple antenna. We're going to talk about some antennas you can build tonight and get on, because in about 2 weeks, I think it's the second weekend in June, is the ARRl VHF contest, and there's going to be a lot of people on 6 meters. You'll make millions of contacts, millions, maybe even more than that. So let's jump over and check in with Glenn and see how Glenn's doing. Glenn, come on in here, man. What are you doing?
Hey, man, I'm just chilling. Interesting you mentioned the 6 meter and stuff, because I had a friend come out and climb my tower for me the other day and realign my beams, and so we have the 6 meter and the HF beam pointing in the correct directions now, so I'm ready. Also got my end fed sort of up in the air. It's got to be tuned or checked, and hang one end up through a tree, I guess, is my best way. It's a little too long for my house, but cleaning some of the metal up out of the air, got my 2040 dipole down, so we're getting closer on all of that stuff, slowly but surely. So I'm getting ready for that 6 meter contest too. That should be great. Fun.
And I bet we might talk on 6 meters.
Hopefully.
But you know what? That's a big band. That is a big band, man. There's a lot of band there.
Yeah, but you're a little too far for me on HF ground wave.
Yeah.
With the 40 meter net, I can't work.
Yeah,
Yeah.
but I'm talking about we got four megahertz on 6 meters. I mean,
Yeah.
that is a
It's
big,
a big band.
and you can be anywhere in a million spots on there, but I'll find you. I'll find you there.
Yeah. Oh no, we'll figure it out.
Let's,
And
yeah.
also, it was fun working with you the other day on that All American 5. I did not mean to stay as long as I did, but man, we were having too much fun.
Well, you didn't stay but like 5 minutes.
No, it was like an hour and a half, dude.
Oh, I didn't know that, man. Well,
Yeah,
time flies.
absolutely.
Time flies when you have fun.
Absolutely.
Right? Time flies. Okay. So let's check in with Brett. And Brett, you gonna join us on 6 meters in a couple weeks?
Yeah, I sure hope so. I'm working on assembling a 6 meter mag loop. It's a little kit that I got from from a fellow who didn't use it. It was made by him in Canada, and it's an interesting device. It was stamped out of sheet metal, and the loop sort of comes together at the top, and there are nylon screws you use to adjust this little gap that serves as a capacitor. I haven't quite figured the thing out yet. I can show some pictures, but I'm still learning how to get this thing going and what it does. In the meantime, my 40 meter delta loop will actually tune up to 6 meters.
It will. Yeah.
Yep. And I do have ham sticks, so I can always go ahead and take my ham stick dipole and refit it for 6 meters. So all of those things are possibility. The nice thing about 6 meters is that it's a nice short wavelength. And so it's really easy to build antennas for. You can build something like a Moxon just by bending some metal, and it's very simple to do.
Yeah, it'd be interesting. Maybe a little later we'll talk about your antenna, the metal, and how the two pieces of metal become the capacitor, and you just adjust the spacing. I haven't thought about that, but that's cool. Now, man, and we all know, man, there's some high voltage on a loop like that. High voltage. So I've been I built one here in the shack one time, and let me tell you, you got to be careful touching around that tuning capacitor while you're transmitting. And let me tell you, 5 or 10 watts generate such high voltages, man. That sucker's still dangerous, man, at 5 or 10 watts.
Oh yeah, well I'd probably use it for POTA, and I'd put it at a good distance away, maybe on another picnic table or something, and watch, who knows, maybe even put up some incident tape around it to keep some people from walking over and touching it. But it's it's supposed to be a very efficient antenna. The thing about mag loops is that on lower HF frequencies, they're so much smaller than the wavelength that they're really inefficient. On 6 meters, not so much. They're actually pretty efficient. So they're great stealth antennas if you're stuck, with an HOA or you're in an apartment.
Yeah. We're going to talk about some different 6 meter antennas tonight. And hey, here's one right here we'll talk about a little later. I mean, look at this, man. I mean, it don't take much to build a good 6 meter antenna.
Mm-hmm. No, you just have to break both legs.
Yeah, you just break both legs, and
yeah, you get it for free, or let your insurance buy it for you.
All right, well, guys, we got some exciting times coming up here with this VHF contest, and I challenge everybody there in the chat room, all of our members here, man, get on, talk to us, try to talk to us. Also, I'm trying to figure out how I can force myself to start getting on HF, maybe on the weekends or something, and let's just get a group together and just talk, man, and have a good time on there. So, okay. Well, let's first talk about the All-American 5 radio that Glenn found for us. And if you guys remember, on the last show, Glenn was walking around in the rain there at Hamvention, and he found this All-American 5. Look at that. So this is a Motorola. In fact, do you think that's an M symbol there in the middle? I don't know what that is.
That may be an early Motorola logo.
It could be. But he found us an All-American 5. And it actually is an old Motorola Model 5C. Now, this is one of the early days, man. I mean, I mean, you ask Glenn to go find an early radio. Let me tell you, he finds an early one. This is probably one of the first ones that came out with the miniature tubes in it. This radio was not just in great shape when Glenn brought it in here, although it did turn on. Let me show you what I pulled out of it actually. Let me see here. Here we go.
Let me tell you something. I was rather surprised about the guts of that thing, all the point-to-point wiring without insulation and everything.
Well, there's not much in there. There were 7 resistors total in that entire radio. Only about three capacitors, really. But guys, this is kind of some of the stuff I pulled out of it. You can see the filter caps here. They had been replaced. These aren't original filter caps. They've been replaced, but they had also gone bad, causing a hum in there. If you look at the wiring here, this is the AC wiring right here, and boy, I tell you what, it is stiff, it's brittle. You bend it, it breaks, and if you look right here, you'll see the bare parts, but it is so stiff. And the tape, they used the tape in a number of places in there. This is the old, I call it friction tape. Maybe it's got a different name, but this is tape like you'd have back in the 1950s, electrical tape, but it's a black cloth tape, and all the wiring and stuff in there, it had this around it, and it was pretty junky. I'll tell you that, it was pretty junky. It didn't sound great when we turned it on. I
was surprised it worked at all. And if you think about it, those caps that you said were they'd been replaced once, those were still paper caps. So who knows how long ago those caps had been replaced, 30, 40 years ago.
Yeah, they're asking if I paid you back the $50. I paid him back $10, 10 big ones. Friction tape. That's what it's friction tape.
And he only paid me the 10 because I threatened to replay the live stream of how much I paid for it. So he had to pay me what
I know. Well, I admit I saw you when you purchased it there. You were awful easy though. You picked it up, and the guy was wanting $20. He says, "I'll give you 10 for it." Man, that's not how you negotiate. You say,
Well, no, you told me. And that's on the live stream as well, to tell him it's for the show and we'll send it back, whatever. And he says, then it's going to be $40. So at that point, me getting him back down to 10, I thought was a major function there.
You're supposed to say, what's the least you're taking? He'll say 10, and you say 5, and then he says 15, and you say, how about 10? He'll go, okay.
See? So I ended up paying the right amount. And
you did okay.
Look how much time I saved.
Yeah, you did okay. But guys, that radio was it's old. Let's see. I think it's probably about the same age as me, and I ache in pain all the time, man. So that radio is also aching and paining. Let me tell you.
But you got to admit, it did work the first time we plugged it in. So
it came on, and we did hear a weak station, and we heard a hum, and we heard all kinds of other stuff, and that was great. Now, the tubes could be weak. We haven't checked the tubes, but at least they are functioning. So that was good. I've got a video here that's going to show us what we did was pulling it out of the chassis and looking for the hum and so forth, and how we fixed that. And you might not hear the hum quite as much on the webcast here, but it was quite loud at times.
Yeah, you had that diagnosed in the first 30 seconds, though.
Yeah. Well, see, I have worked on hundreds of these radios back in the '60s with my uncle in a radio and TV shop, and it was fun looking in one again, And
Put them on a variac, or do you just fire them up full blast and hope for the best?
Yeah, just fire it up, and then whatever don't work or explodes, you just repair it, But you know, one of the things about this one, it looked really junky, Glenn. All the wiring was bare wire, no insulated wire in most places, and they were just almost touching each other everywhere, man. It was like, you know, it was like a spider web in there, and I had to be careful there to keep stuff apart. You know, no power transformer in it. You know, yeah, I got a couple pictures here just to show you the diagram here real quick. If you look at the All-American 5, this is it, guys. This is what it is, and you can see the filament string at the bottom, and on all the miniature tubes, your filaments are pins 3 and 4. So you'll see 3 and 4, 3 and 4, 3 and 4 down here, and that's how when a person would bring one into the repair shop, if the tubes weren't lighting up, the way you would instantly or quickly test it, you'd pull the tubes out one at a time and take your ohm meter. You'd go across pins 3 and 4, and if you didn't have continuity, that filament was bad. So that's how we determined what filament was out. So you can see there. Oh, go ahead.
I was going to say, it's kind of like the old Christmas tree lights.
Yeah, exactly. Except these are easier.
They all go out.
What was that?
One goes out, they all go out.
Exactly.
Yeah, but this is easier to find than a Christmas light, believe me. Yeah. So, you know, you can see your rectifier down there at the bottom, and then the 4 tubes across there that actually do all the heavy lifting. So we're going to look at this in just a minute. I've got a video here just for your information. This is the lineup in here, and we could have done it with the octo tubes. We would have just had to figure out the right pins, the equivalent pins of the miniature tubes. But the first tube is a converter, mixer, oscillator tube. Your second one, after it mixes, it puts out a 455 kc kilohertz signal. That might be the problem with this old radio. This radio had 455 kilocycle filters in it, and you know everything changed to kilohertz years ago.
Yeah.
So that could be a problem. We were running a kilocycle radio on kilohertz.
Yeah, it didn't get the memo.
Yeah. So there's your IF amp, and then from the IF amp we go into our first audio and the detector, and then a 50C5 audio output tube. So that's pretty much it right there. Let me bring up a video. It's like 20 minutes or so, but we're going to go through it, taking it out of the case. We're going to show you what it looked like inside and troubleshoot it real quick. Get it working. And when I say get it working, Glenn, I peaked the IFs, but they were pretty much peaked, but things were still kind of weak. But again, it was a working radio, and that was good. That's what we were looking for. So let me bring it up here. Okay.
I'm just glad we were able to find it.
Yeah, I am too.
Because I mean, I scoured that entire flea market. Yes, it was rainy and a lot of tables were covered, but that was the only All-American 5 that we actually saw.
Yep. All right. I'm bringing up the video. I think I'm bringing it up. Now I'm bringing it up for sure, unless I open it twice. Okay, here we go. It's got to load. This was not a great specimen. It was.
But it is
it was on its last leg. It was on its last leg for sure. You know.
But it's, but it is a testament to those old radios that thing was still working after all those years.
Yep. Well, let's see here. Let me get this just adjust a little bit, and we'll see if we can't get it running here. Here we go. Hey, one of the things we told you we're going to do on the show was to take an All-American 5 radio and turn it into an AM broadcast transmitter. Well, we've been looking for an All-American 5 radio for probably about 3 or 4 months now. And Glenn just found one. Look at this. Just found one up at Dayton Hamfest last weekend. And we're gonna be talking about this in just a moment. And I'll show you a little bit more about it in a minute, but let me tell you a couple things about this. The All-American 5 radio, they built millions of these. Probably more than 100 companies built these back in the 50s and 60s. And it was a pretty simple design. In fact, it doesn't have many parts in it. It's got 5 tubes in it, and all the filaments are in series. And the filaments add up to 120 volts. So they use the line cord voltage to power the filaments. Kind of like the Christmas tree light bulbs today. If one tube goes out, they all go out. So anyway, Glenn brought this back. It's not the prettiest radio, but it was the only one we found there. Let's take a look at it real quick. This is a clock radio. You can see it's an AM only. It's one of the earlier models of it, actually. Let's turn it around and look at the back. You can see this one carries the name Motorola on it, Model 5C. And here's the power cord. The power cord looks like it has been swapped before. Let's plug it in and see. Let's plug it in and see what happens here. Maybe it won't blow up. I don't know. We're going to plug it in. Excuse me. And we're going to turn it on. And it's going to have to warm up. Tubes will have to warm up. Let's see if it works. That's going to be our first step. Ah, got some noise. Got some noise.
Of a faulty calf muscle by Giannis.
All right, so listen to the hum. Listen, you hear the hum? That is a typical problem. That's a typical problem that these radios have. So it looks like it's a working radio. The tuning works, the oscillator's working, the output's working, but we have some hum in it. So we're going to do a couple things to it. First of all, we're going to get it working properly before we make our mods. I know hearing that sound, I worked on probably 100 of these when I was growing up with my uncle in the TV repair shop. And I know exactly what it is. There's a filter capacitor in there. Usually it's a dual filter capacitor, 50 microfarad and 30 microfarad. And it's a dual filter capacitor that's in there. And one side or both sides have gone bad. And we're going to replace that so it's nice and quiet and runs well. Also, one of the things that is dangerous, this is a dangerous radio, the chassis is actually connected to one side of the power cord. So the chassis is actually connected to one side of this power cord, and depending on which way you plug this in, this way or this way, you may have 110 volts on the chassis. And so you can get a pretty good shock with this radio. Most of them were in either wooden cases or a Bakelite type, or maybe a plastic case in the later days. One of the things that was common about it, if you ever lose the knob, if you lose the knob off the radio, like the volume control shaft is metal, and it's on the chassis. So if it stays plugged in, and if you have the plug turned in wrong, the volume control here would be hot, 110 volts, and you could definitely get a good shock. So what we're going to do, we're going to put another power cord on here. I rounded up an old power cord. We cut off something. It's polarized. So we're going to put a new power cord on it and make sure that it's put on in such a manner that the chassis didn't ever get 110 volts put on it. So we'll repair it and we'll replace the cord. All right, so let's do this. Let's take a look at the inside of the radio real quick. To do that, we're going to have to pull the knobs off. We'll pull the knobs off, and we're going to take the back off of it here. this one appears to have the antenna on the back. All right, so, okay, it's kind of frailed, kind of, looks like things have been replaced. There's been some people working on it. So you can see it. Oh, and look here, the tape. Instead of plastic electrical tape, looks like this is the old, I used to call it friction tape or whatever. It's kind of like the cloth electrical tape. So the power goes into the clock. The clock switch turns the radio on or off, and then the power comes back out from the clock switch to the radio. Let's pull the radio out just real quick and take a look at it. So 2 screws here should pull it out. And we're going to see what's going on here. We want a good working radio before we make our mods, so just to make sure it's working. Okay, so all right. So there's the radio. Hey, it's a small little radio, isn't it? Gee. Okay. The dial cord's still on it. Speaker looks good. There are your 5 tubes. There's your 35W4 rectifier, your audio output, which is a 50C5. And we're going to be working with this tube down here. This is a 12BE6. So actually, in our mod, we're going to use this tube, and this tube for our mod. And of course, that's our rectifier that converts voltage to DC. Let's look underneath the bottom real quick. See what it looks like under the bottom. All right. So, well, let's see. I'd like to prop it up somehow. Not sure how I'm going to do this. Yeah, I might get it. Oh, it looks pretty bad in here, actually. A lot of the wax capacitors in here, you can see there are almost no resistors. And I see 1, 2, 3, 4 resistors, 5 resistors in the whole, 6 in the whole radio. A few capacitors right here. The filter capacitor I was talking about has been replaced. You see these this capacitor here and the one below it. That used to be a single capacitor here with 2 leads coming out, 50 microfarad, 30 microfarad. So somebody has actually replaced that before with these 2 capacitors. Let's turn it on and see which capacitor is bad. It's going to be one of these 2 is going to be bad. And what we're going to do, we're just going to bridge. I pulled a, knowing that this was probably going to happen, I pulled a capacitor out of an old board I had. And we're talking voltage is over 150, about 150 volts here. So I had to find one with at least 150 volt rating. This is a 400 volt working volt, 68 microfarad. Now again, they put the proper values in. That's a 50 down there, and that's a 30 right there. I'm not going to worry too much about the 30 or 50. I'm just going to put the 60 in there, and we're going to see how it works. So let's turn it on. Let's see. We'll plug it in. If I can find the plug, here it is. We're going to see if one or both capacitors are bad. And the way we checked this in a TV shop years ago, we just bridged a good capacitor across the filter capacitor, and that would, if that was a problem, it would take away the hum. And then, of course, we would take the capacitor out and we would replace it. So you're going to hear the hum. All right, I think you can hear the hum. Okay. All right. All right, you can hear the hum. So let's do this. Let's do this. We're going to take our capacitor and try not to get shocked here. All right. We're just going to touch our capacitor to these to see which one's bad. It's going to be either this one or this one. Well, that didn't clear up the hum. And that took the hum out. You can hear the hum. You can hear, now the popping, I think my phone that I'm recording with is making it pop. But you can definitely hear, well, let's get the microphone real close to the speaker, a little closer, and you're going to hear the hum. You hear the hum. Oh, there's good, there you go. We're going to touch it. There's the hum. Hum is gone. Okay, so that bottom capacitor is bad. We'll probably replace both of them there. That's going to get back in pretty good working shape. So give me a few minutes and we'll show you the new power cord we put on, and we're going to replace the filter caps. Okay, well, we've got the new power cord put on, and it's polarized. You can see we have a polarized plug here. We have checked the chassis is not hot now. We've rewired the clock, and the switch for the radio is in the clock. I hear a little bit of hum. That's not the filter capacitors. It's coming in. I think it's my fluorescent lights. You can hear the hum get louder when I touch the antenna. So we seem to be doing pretty good. The radio's not real sensitive. I don't know how the tubes check out. They're a little noisy. The mixer converter here. Oh man, I need to clean the pins there. This is the IF amp. A little noisy. Audio amp. Okay. This one's pretty bad. So we need to fix this one right here. Well, that's appeared to have helped a lot. That's a little noisy. We'll do that one.
That's what I want for the parties here. The Golden State Warriors at 46 and 36.
All right, we got all the popping out. Looks like those tube pins were really dirty.
You like that is left off, but
All right.
Steph Curry, Klay Thompson, and Draymond Green presumably coming back. The barometer.
All right, we are about to our next step where we're going to try to convert this to an AM broadcast transmitter. So we'll be making the mods to the radio in just a few minutes. But let me show you on paper what we're going to do. The lineup of the tubes, 1, 2, 3, 4, 5. Line up the tubes are kind of like this. You've got the first tube is the compressor mixer. This is the oscillator and the mixer right here. It mixes the input signals. And the mixer, the oscillator, to come out with a 455 kilohertz IF. So that'd be 455 kilohertz. So the way the radio works, basically, you've got your oscillator mixer, your tuning capacitor, and they're connected. You got your oscillator circuit. It mixes it. It changes it into the difference between the oscillator and the outside frequencies, 455 kilohertz. And then that's the IF. And it's going to then go from there, I guess, through the volume and into a detector, an audio amp. This converts it back to audio. And then from there, we're going to go into the audio power output tube, which is a 50C5. Of course, we got the 35W4 down here. That's the rectifier, DC rectifier. Okay. Now you got to remember all these tubes, the filaments of all these filaments are in series, kind of like this. So they'll all connect like this. And then, of course, this will go out here, and hey, this will go out here, and that's 110 volts AC. So that lights your filaments up in the tubes. 35 and a 50 and a 12 and a 12 and a 12. You add those up, and that's 121 volts. Okay. So here's what we're going to do. Here's what you have to do to make the mod to turn this All-American 5 transmitter into a broadcast transmitter. Did I say transmitter because this is a receiver? All-American 5 receiver. This one's kind of dirty, and it's kind of been modified a few times. I mean, if you look closely, the wiring and everything is all kind of flaky looking. So I don't know, but we're going to do our best to get this thing to work. So basically, here's what we got to do. There's about 4 or 5 little things we have to do to turn this into a transmitter. Number one is on a mixer converter. Well, let's start down here. Let's start at the tuning capacitor. On a tuning capacitor, what we're going to do, we are going to disconnect the antenna from the tuning capacitor. And then we're going to short these two together. And then we're going to hang a little cap there, maybe 100 to 100, maybe 100 to 200 picofarad capacitor. And then we're going to run maybe a 15-foot wire. Okay, that's the antenna. That's going to be our antenna. All right, so up here on the mixer, what we want to do, we're not going to use the IF amp at all. So the IF amp basically goes out of the equation. So we want to disconnect pin 6 from the 12BA6. So we're going to disconnect this lead here. Now there's going to be several different wires. Let me get my other pin. So there's going to be several different wires that connect here to pin 6. You can see I just drew them in right there. They all connect. So what we want to do, we want to take all these wires off pin 6. Take them off of pin 6, and we want to tie them together here. Tie them together and leave them tied together. Maybe put some tape around it or whatever. Just make sure they're not shorting out anywhere. Okay, so that's our first, our second thing. Our first thing is we're going to take the antenna off. We're going to short the 2-gang tuner variable cap, short it together. We're going to come up here. We're going to cut, take all these leads off pin 6. Now pin 6 is open. Okay, over here, pin 7 of 50C5, that's the output. What we're going to do is we're going to run a wire, just a wire from pin 7 over to pin 6. Can you see that? So we run a wire from pin 7 over here to pin 6. Leave the other wiring connected here. What you have here basically is, on this is your output. You have your audio output transformer there, and your speaker is what you have. So just leave that connected. Okay. Now, the other thing we want to do is since we're not bringing in this IF signal into the audio amp, we want to cut this lead. That's one side of your potentiometer is going to be grounded, and the other side, we'll call it the hot side. And of course, that's the variable to get variable voltage into your tube. So we cut this, we cut that. Now there's nothing on this side of the variable cap. That's where we're going to hook our mic. So our mic is going to basically go, our mic is going to basically hook to the top, and it's going to hook to ground like this. So that is going to be our microphone right there. And by turning the volume control here, that increases or decreases how strong the microphone is into this. So basically, we're putting the mic into volume control. It's going into an audio amp, which then goes to the power amplifier, and then it connects back over to grid here of the converter mixer, and this becomes your transmitter right here with your outside antenna or your whip antenna right here. Now, the mic is going to be a little funny here. What we probably need to do, I'm going to try to use the speaker. For the microphone. Okay. So that's the speaker. So I'm going to use a speaker for the microphone. It's got two leads that come off of it. Now what we're going to have to do, we really need to bump this impedance up. This is 4 ohms. 4 ohms right here. We need a high impedance here. So here's what we're going to do. I busted open a wall wart, the old standard wall wart here. This was an AC wall wart, 3 volts, 110 in and 3 volts out. You can use just about any wall wart. And if the primary, it's got the most turns on it, so that's going to be your high impedance, and the 3-volt side or your secondary side is going to have the least in here. So what we're going to do, we're going to take a little transformer. We're going to take a little transformer, and we're going to add it right here to the speaker like this. So there we go. Oop, let me get that coil in here. Okay, so there's our transformer right there. So we got your speaker, 4 ohms, and that's going to go into the low impedance side. And then we'll come out to high. I should have drawn more turns on there. We're going to come out to high side, and then we're going to just take this and just connect it right here like this. And that should allow this speaker to work as a microphone. We'll talk into the speaker. The impedance here is going to get bumped up. We're going to go through. We'll turn the volume up. It's going to kind of modulate the signal here. It's going to go into the audio output over to the oscillator, and that's it. That's going to be what we have to do to make this thing a transmitter. So really, we've got basically disconnect the antenna. That's 1. Put a jumper across. That's 2. Take the leads off pin 6 of the 12BE6. That's 3. Add a wire between pin 7 and pin 6. That's 4. Cut the wire here from that feeds the volume control, so we don't have anything coming into the volume control. So what was that, 5? I've lost count, 5, and then we've got to come up with some kind of little microphone deal here. So it's probably about 6 steps. To make this transmit. I'm going to make those mods now, and let's just see if this thing will work. It may not work. This radio has been hacked. It looks like several times, but we're going to see what happens. Okay, we're making some progress here. The receiver is plugged in. We're actually looking at the oscillator on the spectrum analyzer, and it's right now it's about 930 kilohertz. we had to make a few modifications, a couple extra modifications when we took the wire off of the oscillator. And down here, when we took the wire off the oscillator, it also removed the screen voltage, and it wasn't oscillating. So we added a resistor. We just arbitrarily picked a 4700 ohm resistor and went from B plus to pin 6 of the oscillator. And once we did that, then it started oscillating again. So you can see as I tune the radio, you can see the spectrum analyzer. You can see the output is changing frequency. And so right now, right there is about, well, 930 kilohertz. So we got an output of 930 kilohertz. Let's turn our little Radio Shack receiver on here. And let's see if we can tune to 930. All right. All right, we're going to go to 930. There we are. Hey, you can see we have a full signal. Let me tune the All American 5 transmitter. You can watch the signal here. We're on 940. Okay, there's no carrier, no signal, no carrier. I'm going to tune the All American 5, and you'll see the carrier come in. You'll hear it get full quieting. Okay. So we're transmitting. We're transmitting from the All American 5 to the Radio Shack. Oh, I did something here. I messed my radio up. Ah. Okay, I didn't have batteries. Didn't have batteries when I moved my radio. The power plug came undone. So anyway, okay, so we're putting a carrier out from the All American 5. The radio's picking it up on 940. Let's see if we can. It's full quieting. Let's see if we can send some audio through it. Oh, look at there. So when I touch our audio input, let me moisten the finger a little bit. There we go. So if we hook our microphone across this is the audio input. You can see it sounds pretty strong. Of course, we're sitting very close right here. Let's see if I can separate just a little bit. We'll just put it over there. Well, I can send CQ. Okay, let's get a microphone hooked to this thing. Maybe use the speaker, and we'll see if we can send some audio from here to here. All right, ready for our final test. I think we finished this up. The All American 5 converted as a transmitter. What we done in our last step here, what we did was we're going to use the speaker for the microphone. This is the audio output transformer. That's the 50C5 audio output 2. That's the transformer. This transformer normally, drives the speaker from the output 2. We've completely removed this transformer off the output 2. And we're going to use it as an impedance matching into our audio input. So, speaker is a mic, about a 4 ohm speaker going into the 4 ohm side of the transformer, and we're coming out high impedance. And then I just extended these two wires, cut them off of the 50C5, and we hooked these two wires here on the on the volume control, which allows us to adjust the amount of audio drive that we have. Let's plug it in and see what happens. All right, tubes are warming up. If you watch the scope here, we'll know when the oscillator comes on. It's probably going to come on. Let's see. There it is. Okay, the tubes are warming up. You can see the oscillators coming up, and we're on about 1050, somewhere there about 1050. So let's turn the radio on, 1050. And our radio is on 1050. And let's look at there. We have a transmitter. I'm gonna try to talk. Let's see if I can do this. Don't know if I can do this or not. Mic test 1 2 3 4 5. Mic test 1 2 3 4 5. Mic test 1 2 3 4 5. Okay, it looks like we have a working transmitter. We're using the speaker for the microphone. I've got a little 24-inch piece of wire clipped on here for the antenna, and of course there's our receiver. Got feedback. Okay. Hey, there we go. Now we'll just put it all back together in the case, and we'll have a working All-American 5 as an AM broadcast transmitter. All right, guys, I hope that wasn't too long and too boring for you, but you can see we went from a pretty crude radio to a pretty crude transmitter, but it did transmit with the modifications. We had to make a modification that we didn't think we were going to have to make I thought, oh man, hey Glenn, I made that mod to get that oscillator running, and when I did that, it had nothing. I looked on the spectrum scope and there was nothing there, and I go, what in the world's wrong? So that's where I had to get some B+ back over there to the oscillator, and once I did that, it came up there on the spectrum analyzer. So it's pretty ragged inside, and it was dirty and ragged, and the tubes are probably pretty weak, and but hey, it worked, and that's what we wanted. That's what we wanted to do on a show. Show you how you can take an All-American 5 radio and turn it into a transmitter. Yeah.
Well, you know, I got all these tube testers over here.
Oh yeah. Well, you know, once I got it working, I buttoned it up and I threw it here on the floor, and I don't know what I'm gonna do with it now. Maybe throw it in the trash. I don't know. You know, it's not really practical to me. Hey, back when I was a teenager, you know, in 1960s, early 60s, that may have been something to have fun with. You know, have your own radio station. You know.
Well, if you remember back in the day, you know, there was a lot of those electronic kits that would build your own AM band transmitter.
Yeah.
So it was legal to do with like 100 milliwatts or whatever.
Yeah, and you know, I think as long as you don't interfere with anybody and you know cause problems, you're probably all right. And particularly the short amount of time you'd ever be on. You're not going to be on, 18 hours a day, guys. But here you go. There's some of the junk that came out of it, and when I say junk, I mean junk. And this is not original. This is replacements. So these aren't.
But Tom, you need to find who did that and demand your money back.
Yeah.
Because if you look on those capacitors, there's a warranty. Those capacitors are guaranteed for 1 year.
Yeah. Well, it might be for 1 year.
And you've only had it for what, 6, 7
Yeah,
days.
I would imagine that capacitor was probably put in about 50 years ago.
At least, yes.
Yeah, man.
I haven't seen a paper capacitor in forever.
And the wire here. I mean, look at this. It won't even bend. It's so brittle. I just bent it and a piece of insulation popped off and went over on my laptop.
That's typical.
I mean, it's let's see. I don't know if you can hear something.
Yeah, that's typical for the old
Oh man.
cords from that era.
Yeah, it is. It is. So, and that cord's been replaced, but look at it now,
Yeah.
man. I mean, it's oh gee. And I haven't seen this kind of tape. I probably used it when I was a teenager, but I'm trying to think when we had plastic tape. I mean, I don't. I can remember this tape, but I don't remember using it that much.
I remembered using that. That was what my dad had for electrical
Yeah.
in the
I used to use
60s,
that too.
70s.
Yeah. Yeah.
Back in about the 1960s.
Yeah.
Oh, yeah.
Very,
That's about right.
Very long ago.
That's about right, man. Well, anyway, guys, there you go. I don't know what I'm going to do with the radio. It's sitting on the floor here.
Well, Judging from the chat room, it sounds like there's several that wouldn't mind winning it through Hambot.
Really? Oh, man. Well, I tell you, I wouldn't count on great distances with it. I wouldn't. I don't know what I'd count on with that radio. It's pretty junky. It's pretty junky inside. Glenn picked out one of the junkiest radios we could have had to use. He really did.
I picked out the only one.
I think he did it just to make things a little difficult for the show.
Well, we just had to prove how good you were.
Well, when I first made the mods and turned it on, it didn't work. I'm thinking, oh no, man, do I need to cancel the show from now on? You know?
Yeah.
Yeah. Oh man, these dirty capacitors, they're getting my table all dirty here. Gee, I'm gonna have to clean it up here. Anyway, we'll decide what to do with it. You know, clean it up, put some decent parts in it. Well, yeah, we could definitely get our money, but I could get $10 for it. I could put it back to where it would work and not have the buzz. But this is not one of the collector models. The All-American 5 that are collectors are the ones in real bright cabinets, like yellow cabinets, red cabinets, green.
Yeah.
You know, those baked lacquer plastic cabinets. So, and they're going, man, those suckers that go for $100 easy. You know. This one right here is worth about $1.20.
Yeah. Hey, at least we found it. At least you made it work. You know,
Yeah.
that's what matters. And you only paid $10. I mean, you looked on eBay and people were wanting $60 and $70 for those things.
Yeah, they do. All right, guys. Hey, we had fun there. Hey, let's take just a half-minute break. We'll be right back, and I want to talk about 6 meters here in a few minutes. We'll be right back. Don't go away. ICOM's compact IC7100 and the IC5100 D-Star mobiles are road ready and features a dash mountable touchscreen control head with quick and straightforward one-touch operation, keeping you connected whenever you roam. The IC7100 is an HF, VHF, UHF multiband all-mode mobile with an angled control head, a large internal speaker for clear digital audio, and fully covers the HF 50, 144, 430, and 440 megahertz amateur bands. This radio provides 100 watts on HF and 50 megahertz bands, 50 watts on 144 band, and 35 watts on the 430 megahertz band. The IC5100 is a VHF UHF dual band mobile with DV dual watch, Bluetooth, and an integrated GPS receiver. For more information on ICOM radios and locate a dealer, please visit icomamerica.com/amateur. All right, and we're back there, and we're going to talk just in a couple minutes about 6 meters and all the great things about 6 meters and why it's so great and why it's called the magic band there. Let's see. Mark in the chat room said Christmas coming up. I might give that radio to somebody for Christmas. I don't know. I might send it down to Glenn. I don't know, man.
Now, I ain't giving you your $2 back.
Yeah. All right. Well, you've got a short memory. It was 50. Yeah, it was $50. Oh, plus, hey, the repair job, the capacitors and the repair was about $75.
Oh, I'm sure. Yeah, in 1950s money even.
Well, that'd been about $7.50 back in. That might have been right. I don't know. You know. So, all right. So let me see what's on my list here. Let's see. Hey guys, I want to talk a little about 6 meters. And then, hey, Brett's got a neat little 6 meter antenna there. It's an experimental antenna he's going to show us. But I want to get back on 6 meters. Let me tell you, 6 meters is called the magic band. And it does have some magic in it. And typically May to August is when that band is the hottest. You might think right now if you tune around on 6 meters and nobody on there, well, I think the band is working. It's just nobody's there, to tell you the truth. Back when I got on 6 meters back in the early 60s, it was AM, and boy, it sounded so good. And, you know, I would talk to people up in New York and just all around, you know, on 6 meters, and really had fun. It's called a magic band. The ARRL is going to have their VHF contest coming up the second weekend of June. That's June the 8th through the 10th. And there will be a lot, since 6 meters is considered VHF, there will be a lot of people on 6 meters. On sideband, on AM, on FT8, digital, all kinds of stuff. There's going to be probably hundreds of people on 6 meters. So I want to get a 6 meter antenna up and have some fun, you know, make some contacts. And the way that the ARRL, I'm not going to enter the contest really, but the way they do it is this, see how many grids you can work. The 2 mile by 3 mile grids or 2 by 3 grids, just to see how many you can work. And I usually don't turn anything in for these contests, but you know, that'll be a good time to test your antenna and test your radio and have fun and see how it is. You know, the thing about 6 meters is it's VHF, but it also has characteristics kind of HF. It's kind of in the middle. And years back, I forget what years, it was probably in the 70s or so, but 6 meters was so good into Europe, it was much better than the HF bands were. And it was a very interesting time there with the band openings on 6 meters. So I want to get an antenna up. Now I have a out in the garage a MFJ tri-band vertical antenna, which is 6, 2, and 440. So I might put that up. I've got 100 feet of basically LMR 400 over here, and I've got my rope over the tree out there at about 90 feet, where we tried to put the GMRS repeater up, if you remember that back a while back. So I'll pull that 100 feet of LMR 400 up and put me an antenna up there in the air and bring it in the shack, and I should have an antenna. Now, that's vertical. That's vertical polarization. There's a couple different antennas that we can do. I think I showed you guys a couple weeks ago the J-pole antenna that's built out of copper. That's a pretty big antenna. That sucker is about 13 or 14 feet tall, but that's a good antenna. It's made out of copper. It's a J-pole. You can actually build it out of open wire feed. You know, your 300 or 600 ohm open wire feed, and it can actually become the same thing as this J-pole here, except it's just with a piece of wire. So there's a couple different antennas we can do. We can do this. I may pull this up. I've got one of these I built. There it is again with some dimensions. You can find these anywhere on the internet. Let's see. What is this one here? This is kind of cool. This is more of a coaxial dipole, where you just extend the center, you take the shield off the top 1/4 wavelength, and then you leave the shield on the bottom 1/4 wavelength, and that basically makes a halfway vertical. And of course, they got a dirty ballon there at the base here to make that work. Now, there's a lot of things you can do. I mean, look at this. I mean, this might be a good antenna for us to try right here. This is the crutch antenna. Glenn says you got to break both legs though to operate this one. But that's the crutch
Now,
antenna.
there's also something to talk about here. And up till now, you've been talking about vertical antennas, and this is a horizontally
That's right.
polar antenna. And that's one thing you need to realize about 6 is, for the best performance, you can work in just about anybody with a piece of wire.
Yep.
But for your best performance, if you're going to work sideband and CW, you're going to want a horizontally polarized antenna. If you're going to work the FM repeaters there on 6 meters, then you'll want vertically polarized.
Yeah, but you know what? Regardless of what antenna you have, you're going to work each other. You just will.
Exactly.
You may be a little weaker. You may be a little weaker. I think somebody says there's like maybe a 3 dB difference between vertical and horizontal polarization. I don't know, but you'll work them. And unless you've got the two antennas up there side by side to compare, you won't probably even know the difference. But Glenn is right. If you want to work sideband, it's preferable to have a horizontal antenna. And if you want to work, I guess, FM or repeaters, then the vertical is good. Now, one thing about it, if you put a typical horizontal antenna up, most of the time you have to turn it because, it's horizontal. And it's like either a beam or a dipole, and you got to turn it. But we've got a fix for that, and I've got it right here, and I'm going to show you. I built one of these. I don't know what happened to it. I think over the years I broke it, threw it away, did something. But it's called a let me find it. It's actually called I'm getting it.
Turnstile?
A turnstile. It's a quad turnstile is what it's called.
Yeah, there you go.
A quad turnstile. And it's really easy to make. Look at it. It's just two quad pieces of wire, 90 degrees from each other. Now the nice thing about this is, this becomes a horizontal polarized antenna, like Glenn was talking about. Plus, plus it's omnidirectional. This antenna is actually omnidirectional because you've got your two different elements here at 90 degrees out of phase from each other. So I want to build me another one of these and get it up. I don't think I can get it up before time for the VHF contest, but it is it's pretty good. There's an article. Let me show you the article in, I think it's QST, where you can build this. A great article, and here it is right here. It's called a 6 meter quad turnstile, and this was, I think this is this is QST. This is May of 2002 QST. So they show you here basically. There's the antenna. They show you how the wiring is. Now they went to all this trouble, and I'm not going to do this, and people will say, "Oh, look at the pattern there for it to be horizontal. It's just about perfect in all directions there." They tell you how to build it. Very simple. But if you notice right here with the mouse, they put connectors on. Yeah, it's a lot of work to put all those connectors on. Look at that right there. Look at that, and hook all that up. I'm not going to build it with connectors. I'm just going to take my coax phasing matching cable there. I'm going to just neatly keep the ends very short, tie it all together, solder it up, and I'm going to weatherproof it. And I guarantee you it will work. And if you took it to a lab and they took one that had the coax connectors on it and compared it to mine, yeah, there'd probably be a difference. There probably would be a difference. But, hey, mine's going to work. So I've got to do that. Now, one of the things is that the matching, the phasing line right here they use RG63. Now, I need help. Everybody out there in the chat room, I need your help. I thought I had some. In fact, I bought some when I built this last one. I was looking in my closet here for some RG63. I can't find it. I need RG63. The stuff's a little expensive. Let me show you how little expensive it is. Here's a site here. RG63. Look at here, $4,318. That's for 1,000 feet.
25 ohm. Okay.
Yeah, it's 125 ohm. Hey, $4,000 or 1,000. That's $4 a foot. All right. You think, well, that's high. Let's just go to another site. All right. This is a 10 foot piece here. $75 they want for it. Let's go to another one. Look at this one. Here we go. 1,000 feet again. 4,300. The wireman here, but here's my problem. Everybody, this says out of stock. Everybody's out of stock. Let's go up to Canada. No wait, that's the U.S. again. That's $4,000. Let's go to here we go, $6,000 for 1,000 feet, but that's Canadian dollars.
Does it need that second conductor inside there?
There's only one conductor.
Look at that. There's a white.
That's a white piece of Teflon or something that's wrapped around that.
Okay.
So that's to make it very low loss. This stuff is very, very low loss. In fact, that center conductor is like a little tube with that solid wire through it, and then they wrap that solid wire. Helicky wrap it with a little piece of looks like plastic to kind of hold it in place, you know.
Okay.
But look at it now. So here's what, guys. I need to buy a 10-foot piece of this. I'm going to buy a 10-foot piece. I need to find it. So I want everybody, and I have wore out the internet this afternoon looking for it. Find me some RG63. I'll order it.
Does it have to be 63?
Well, it needs to be 125 ohm.
Not a problem.
What do you got?
I've got 1,000 feet for $179. Mouser's got it for 120.
All right. Now I looked at
As it turns,
huh?
yeah. Allied wiring cable, Belden, Omni cable. Everybody's got 9857.
Is that the Belden 9857?
Yeah, it's RG63 125 ohm.
Yep. Okay. All right. So, and they've got it, huh? And how much is it?
I'm looking into that now because everything I had was for thousands of feet.
Yeah. Okay. Well, how much was 1,000 feet? Was it like 4,000?
$179.
For 1,000 feet?
Yeah.
No.
Yeah.
No. Something's wrong.
Yeah.
1,000 feet for $100. That's 10 cents a foot.
Dude, I'm sitting here looking at it.
I think your eyes are crossed.
179.17. Oh, that's RG58. Never mind.
Yeah, yeah. And that's the thing. I can search all day for this RG63. And when I do a search, it pulls up other coax that is not RG63. You know, typically RG6 pops up all over the place, man.
Correct.
Yeah. But, yeah, well, okay, so back to that one. Is that a no-no?
Yeah, that one would be a no-no,
Okay.
but I'm finding.
All right. So, guys, I'm looking for. Mark there said he had lots of. What do you have? Lots of. Let me look. I've got a heart on my chat room. I've got a heart that covers up one of the words. I don't know. I hate that.
Well, type something, it'll roll up above it.
Yeah, that's a good idea. Good idea. Good idea. Let me just type something. It did. I had a lot of fun on. Oh, okay. Check out ABR. Chris says in Houston. I have checked, man. I look for hours today. Hours. So guys, hey, help me out here. Do a little search. RG63. You know, I found some sites that had it, but they wanted me to buy a 1,000-foot spool, and I don't want to buy a 1,000-foot spool. You know, I just don't. You know, actually, I need 5 feet, but I'm going to buy 10. I've sent a note. You know, Times Microwave is a sponsor. Then we give away coax from Times Microwave, and I contacted my contact there just to see if they have any. When you do a search for Times Microwave for RG63, it pulls up their coax screen, but I don't see RG63. So I'm asking if they got it. May send me some. Mark says, oh, he's see if Midwest says, okay. So guys, find me some RG63 so I can build this antenna, and I'm gonna pull it up out there, and you know. But man, 6 meters was so much fun back in the '60s. I remember going to New Jersey. I was 16 years old, and maybe actually even younger than that, with my uncle. This is not his car, but we went out one night. You know, back then to work up there like 6 meters, he would get in the car and go out in the country somewhere with a halo antenna, and that's how he would make 6 meter contact. So there you go, right there. Halo antenna. That was an antenna back in the day. You know, Glenn, I save everything. I save everything right here. Hey, here's a reminder about saving everything. Look at this breaking news. Ham radio operator uses coax that he put in his garage in 1976 in case he needed it. Look at here. He needed it, man. He had it.
Finally needed it. Yep.
He had it, man. All right. So, yeah. Okay. So we need it now. Let's talk. Let's talk a little about. Let's get Brett in here. Brett, you got an interesting antenna there. You want tell us about it?
Okay. Well, let's see. What I have here is an interesting 6 meter antenna that's good for apartments. It's good for POTA. It's the 6MF 6 meter antenna, and it's an interesting device that you can sort of see here. Here they stamped. They did a really neat job of machining this. Here, I'll flip it over so you can read the lettering. They took a metal plate and they stamped this out of sheet metal and made a mag loop. And so what we have here is a loop of sheet metal. At the top, there are 2 plates that are bolted on.
Yeah.
And they provide a gap, which becomes your tuning capacitor. And as you can see, there's a little nylon screw here, so you can adjust the gap. This tunes your antenna. And then down at the bottom, you have your SO239 and a little loop inside the big loop, which is the coupling to it.
Yeah.
And the whole thing, it's got to weigh less than a pound. And
Yeah, that's cool.
small and it's convenient. And again, you can put this thing inside your apartment. And they sold about 1,000 of these. These were created by a Canadian ham, VE3 UK, who went by the name Antenna Crafter. I don't know if he's in business doing that anymore. And if you go onto YouTube, you can see a really good assembly video which shows how you assemble this thing.
Well, I like the loop here, and the loop. I don't know how they came up with this. I guess somebody figured it out. The loop is like 1/5 the size. Typically, it's 1/5 the size of the overall loop. Here's a couple loops I was using right here, and made it out of copper pipe. So that was pretty good. That fits one of the loops, magnetic loops I got out in the shop that I was building. There's one there, just some wire. I mean, it does the same thing. And also, Brett, just by moving this loop, actually can change the SWR or tune things. So now his loop is fixed, I think, on there. So maybe he's already got the sweet spot figured out, or maybe not. I don't know.
Well, this one, when I've experimented with it using the little MFJ antenna analyzer, I've been able to get it down to nearly 1-to-1 SWR on 6 meters. So it sure seems like it'll work well as a mag loop. I've got to take it out to the park and really give it a workout during the upcoming event to see how well it works.
Yeah, well, that is cool, man. Or now, you also have your 40 meter delta loop up, and I do too. And you mentioned earlier it will work 6 meters, and yes, mine will too. So that's one thing about the loop, the loop or the delta loop. I mean, it will work all the other bands all the way up here. It's a good multi-band antenna.
Yeah, the only bands that it doesn't always work well is some of the work bands. It just can't pull it into resonance.
Right.
But most of them it can. And if your wavelength's a lot shorter than the antenna, if the tuner is good, it can find the sweet spot where it makes it resonant anyway.
Uh-huh.
So I definitely, I recommend that. You can do a delta loop. You can do a horizontal loop around your house, hidden. You can even use your rain gutters as a horizontal loop. And if you got a good tuner. The one which I'm using is the the SG237, which was done by SGC. It's now discontinued. But you can use you can use the LDG. You can use pretty much any antenna tuner to bring a loop into resonance.
Yep. Well, I'm looking forward to this and trying to get on some 6 meters. It's gonna be interesting, and there'll be plenty of people to work. I guarantee you. You get on during the CQ, what is it, CQ's contest? Oh, ARL's contest. You get on that, and there will be plenty of people on there. And that's the funny thing about 6 meters. It sounds dead, but the band's really there.
Well, that's the other thing you can do, especially if you're using a mag loop, which is really, which has really high Q, and so you tune it to one spot, and it's very selective. Is use a mode like FT8 where everything's in a very narrow range of frequencies. Then you can tune it once. You don't have to retune, and you can work hundreds and hundreds of hams all over the world.
Yeah, well, I have found FT8's a good program. I mean, it will work. It will work when you think nothing will work. It'll work when you don't hear anything out there. But I have found that you can make contacts just about anywhere on FT8. I don't care what kind of antenna you got. You can hook it to a window screen and make FT8 contacts, or a light bulb, or a hot water heater, or heck, who knows? You can lay a wire on the ground out there and make FT8 contacts, man. It's just great. You're gonna make contacts around the world, man.
Yep. And if you'd rather reg choose than just make, just make really quick QSOs, you can use JS8 on that band too.
Yeah, and they've come out now with that automated FT8. I couldn't get it to work on my laptop here. I need to work on it again. Where you can just turn it on and leave the house for the day and come back, and it'll work 100 countries, man. All by itself. You don't even have to be here.
Yeah,
there's
there are
one
two
thing.
automated mods of FT8. One is WS. What is it?
WSJT
Z.
Something. Yeah.
And that one works okay, except in contest mode. They have a contest mode, which is broken now.
Yeah.
And then there's another one, which is an add-on program written by this fellow here in Wyoming that controls the original version of WSJTX, and just somehow pushes all the right buttons faster than you can.
Well, that's cool, man. That's cool.
Now, one thing that you've left off talking about 6 meters that has been one of my favorite things, and that's the tropospheric. What do they call that? Induction
Ducting or something?
Ducting, yes.
Yeah.
I love that because the last time I was on 6 was probably about 8 years ago, and we caught a duct as it was moving from east to west, and we actually saw it a couple days earlier over Europe, and sure enough, it made it stateside, and we tracked that thing from east to west all night long, working people on 6 as that thing would move across the country. And it was just absolutely hilarious and fun tracking that ducting. And I mean, like you're saying, the sound crisp, clear, no noise. That's one thing about 6. It's such a high frequency. You don't have a high noise level on that band.
Yeah.
It's kind of like listening on 2 meters. It's quiet.
Yeah.
But summertime is when you get a lot of that tropospheric ducting. So that's something also to look for.
All right, let me just make a quick announcement here. You've been listening to Amateur Radio Roundtable, a show about ham radio and shortwave. We're glad to have you tonight, especially if you're out there listening on WBCQ. You can join our show on Tuesday nights just by going to w5kub.com, and you can find our chat room and video there. It's the easy way to go. Join our Facebook group. It's called W5KUB. Hey, hit the like, hit the subscribe, hit the, what's that other one? Notify. Hit those buttons, guys. It helps us out a whole lot. Wow. Hey, we've had a good time tonight. We got just a couple more minutes before we go off here. So, hey, I'm really excited about this 6 meter thing to get something going, Glenn.
Yeah, I miss the group that we used to have. You're talking about HOAs and antennas. One of the gentlemen that was on part of that group that would do the 6 meters, he actually had a 3-element beam in the attic of his house with a rotator because it was so small. So
you can also do ham sticks. The
Yes.
ham stick dipole I showed a while back. You know, the higher the frequency, the better a ham stick dipole works.
Anything works, man. Let me tell you, my opinion is anything works.
absolutely.
Anything works.
You know, same thing with SWR. Don't obsess over the SWR. If your rig is not in danger, there's nothing wrong with 2 or 2.5 to 1.
I could put a dummy load on the end of a 50-foot piece of coax and hang it over a tree limb, and I'd still make contacts.
Well, you know, there's a group that's actually making contests with light bulbs.
Yeah, and they're actually trying to see who can outdo the distance, but setting a light bulb. Now, I don't know. There's got to be some rules with that. I mean, you know, what I read about, they were sitting it in their window and making contacts 2,000 miles away. But I mean, you know, hey, if I put a light bulb on the end of a 150-foot coax and get it in the air, I mean, you know, it's going to get out, you know.
Yeah, but I don't see any rules being broken there.
I can
You're
put
still using a light bulb.
I can put a dummy load on it and still going to get out because the coax is going to radiate FT8,
Yeah.
you know.
Very true.
Yeah.
But at the end of the day, if you're talking the light bulb, your coax is not going to radiate as much as the light bulb. So, okay, you got a light bulb up at 40 feet. What's your advantage? A little bit of height.
Yeah.
What happens if I lived at the top of a condo? You know, went out on the roof or whatever.
Yep.
So, I mean, no, I don't see that as an issue. I just, you know, I think it's just you know, adding, you know, proof to the statement of you can work anybody with any kind of antenna.
That's true. All right, guys, we've had fun tonight. I hope everybody enjoyed it and stuck around with us. And hey, just real quick, anybody in the chat room, have you got your prizes yet? I'd like to know if anybody's got your prizes. Tell us in the chat room if you got your prizes from the Hamvention webcast that we did. We'll see what kind of delay we have here. Surely somebody's got their prizes. Although, you know what? We may have given prizes away to a lot of people other than those that are in the chat room here. I don't know.
Oh, by the way, while we're still here,
Yeah.
did you hear the attendance of Dayton this year?
I heard it's 38,877.
No, it's 35,000 something, but it was an you know, another record. But
Really?
it did not feel like 35,000 there.
Well, I've got it in your Facebook group in there. I just read it. I wrote it down right here. 38,877.
That's not what I saw 35 in my
Yeah.
feed.
So I don't know, man. You know.
Yeah.
I don't know. Of course, you know, they say they claim that was a record, but that's not a record. Here I had more than that. I think.
According to Dayton Hamvention home at hamvention.org, 35,877.
35,877
It is a new record
for maybe
for Xenia. I don't know about Hera, but it definitely is a new record.
See, I had 38,877. You're saying 35,877. I think
I'm looking at it on their website. It's
I think
35,877.
I think whoever posted that may have made an error, or I may have made an error when I read it.
I'm going to say you made the error because this is Dayton Hamvention's homepage.
I think I didn't make an error. I thought
wait.
I was wrong once. No, wait a minute. I thought I made a mistake once, but I was wrong.
You're wrong, yeah.
Yeah.
But according to Chairman Jim Storms, 35,877. Either way, the thing about it is Xenia is so big. That fairgrounds is so big. I did not feel crowded
Yeah.
at all. No, I mean it did not look. I mean, I made the comment several times. It doesn't feel like
Oh yeah, it looked empty out there in places.
35,000
It looked
people.
empty.
the only time that you felt that it wasn't was at lunchtime when all the lines were,
Yeah.
5 miles deep going to the food places. But 35,000, almost 36,000. That's still amazing to get 36,000 hams in one place. So, nope. Looking forward to next year.
Yep. All right. I will confirm. I went to this page. It's not the Dayton page, the one I read. I will confirm that they quoted. Listen very closely. They quoted 35,877.
There you go.
So I was wrong.
Oh my God, you weren't supposed to admit it.
I was wrong. I was wrong.
You weren't supposed to admit it.
Well, I was waiting for you to say, see there, 35, 30.
Nope. I was going to let you get away with it.
Yeah. Yeah. All right.
No, there's no reason, don't need to rub it in. But, either way, that's a very, very good number for this day and age. So
I think it helps to open it up free to anybody on Sunday and see what they
absolutely.
do to try to get accurate numbers. They when anybody comes in, they give them a ticket.
Yeah. Now, the people that ran the bed and breakfast where I stayed at, they were making plans to attend on Saturday, and they're not hams
Yeah.
or Sunday.
Yeah.
So, yes, that free ticket to get in definitely helps get new people into ham radio and into Dayton. So it's working.
Yeah. Okay, guys, I saw a comment here about somebody may be in the old chat room. If you're in the old chat room, you're in the wrong place. So we're here. All right. Good night, everybody. It's 73. Enjoyed it tonight. We'll see you next week, and maybe Brett. Let's see next week, man. What are you gonna have for us next week, Brett? You gonna test that loop out or that?
That's one thing I haven't decided yet. That's certainly one thing I can do. Also, still working on more music.
Oh no, man! More music, huh?
Oh yeah.
All right. Well, so far Facebook hadn't hit me with your music, so we're okay so far.
Well, maybe they know. Maybe they know it's original.
I get hit every with our opening the best, our intro. I get hit every week with a copyright on it, and they tell me that they have turned off our video in certain countries, and those countries are Belarus and Russia. So because we play the song the best, our video cannot be seen in Belarus or Russia.
A Tina Turner turnoff.
That's right. That's right.
There you go.
Yeah. All right. All right, guys. Good night, everybody. We're going to get out of here. I'm going to get some popcorn and do something. I need to go back and get some rest tonight. Yeah, I got to go to the dentist tomorrow. I found something back there. They're going to take a crown off and put another crown on. What do you think about that, man?
Fun.
Hey, I get to get the
Yeah.
gas tomorrow, man.
Man, there you go.
I get to get the gas.
You're in good company, Tom. I lost a filling last week, and I'm going to the
Okay.
dentist tomorrow to get that replaced too.
Yeah.
Gee, I got my crown last night.
What time's your appointment? I'll be feeling good at 2:00. What time's your appointment?
Oh, well, not much different. 10 a.m. Mountain.
Okay. Yeah, that's okay. Well, hey, last time they said, you want gas? I said, sure. Sock it to me. So they put it on, and I didn't feel anything. I mean, I couldn't tell I get any gas. I said, yeah, you must not have it turned up very much. And they said, oh, you're not feeling nothing? I said, no. I said, well, okay, we'll turn it up some. So they turned it up, and right about in the middle, I gave another sentence, and right in the middle of my sentence after they turned it up, the sentence kind of went, kind of like floating around, and I can't believe that you can drive home after you do that. But they tell me that with the gas, when you get off of it, you're able to drive. So that's kind of cool. I've only had gas at one time before here, and it was okay. It was okay. So I think I'll take it again if it's free.
There you go.
Yeah. Oh, let's see. Chris said in Belarus, they might be able to hear us on WBCQ. I don't know. There's no way. There's no way to stop the shortwave from getting there. So
That's true.
They may hear it there. Yeah.
There you go.
Yeah. All right, guys. Good night to everybody, and get this dentist thing done and get my antennas up, and we're gonna have fun this week.
Sounds good.
All right.
Three.